This is the Positron, a kind of special 3D printer. It's engineered with love, fits into a box of filament, comes with a heated glass bed and prints upside down? That got me thinking, how does printing upside down affect overhangs, supports and overall print quality? Could it even reduce warping with ABS or ASA? In this video, we'll find out and answer the question whether you should flip your 3D printer. Let's get right into it, here at JanTec Engineering. Thanks to Fanttik for sponsoring part of this video. In case you haven't heard of it, the Positron is an open source project based on the work by Kralin3D. The idea was to develop a compact yet capable 3D printer that fits into a box of filament without sacrificing a lot of build volume. Over time, this idea evolved from concepts and prototypes into a finished design that is available as a DIY kit from LDO Motors. I first saw it in person at LDO's booth during the Rocky Mountain Wrap-Up Festival 2024 and got to see a lot more of these printers later that year when I attended 3D Printopia. I remember people working on their printers in the hotel lobby in the middle of the night. Ever since, I wanted to build my own Positron. Jason from LDO was kind enough to provide one of their premium kits, and I finally got to assemble it a few months ago, just in time for our local maker fair in Hanover, Germany. People loved it and asked the same questions you probably have. So let's answer a few of the most common questions before we get to the testing. Why does it print upside down? Because it can. No, for real. With the idea in mind to have a compact and portable 3D printer, it makes sense to have the XY motion and all the electronics in a solid base. Lifting the gantry or fixing it at a certain height adds parts, weight and volume. The Z-axis folds, which makes the whole machine super compact. As said, it even fits into a box of filament. How does it heat the bed? It's heated by a so-called ITO heater, made of a thin indium tin oxide film, which electrical resistance produce uniform joule heating when voltage is applied. This type of bed is limited to 85 degrees C though. There is a high temp PCB bed option for engineering filaments, but then watching the first layer gets harder. And because a lot of people asked, yes, parts stick really well, but I used some Vision Miner nanopolymer adhesive to be extra sure. Where can I buy it? It's not available as a pre-built machine. You can self-source the parts or get a DIY kit from LDO Motors. I'll put links to some vendors in the video description. There is a cheaper kit on AliExpress, link is also in the description, but I'm not sure if its quality is as high as from LDO. You'll also need the printed parts. I made mine with Prusameters Natural ASA and Nobufill ASA X CF on my Prusa Core ONE and MK4S. Is it worth the price? Probably not, especially compared to modern plug-and-play printers. But I really enjoyed tinkering around with it and it's a beautiful piece of engineering. It reminded me of how I started my 3D printing journey, where I spent more time installing upgrades on my 3D printer than actually using it for printing. What's the advantage of printing upside down? How does it affect overhangs, bridges, stringing and supports? This is why I'm making this video, to answer all these questions. At Maker Faire, I simply replied that it shouldn't have a significant impact, but now it's time to find out. Oh, and don't forget to subscribe to this channel. So far, only a small percentage of you are subscribed and it really helps the channel. Thank you. Comparing a different printer like the Prusa Mini to the Positron would be a huge mistake. Overhangs, bridges, stringing and so on highly depend on the printer's mechanics, part cooling and slicer profiles. And we don't want to compare apples with oranges here. That's why our samples should be printed with exactly the same G-code on the same machine. Flipping the Positron to make it print right side up would be funny, but not practical. That's why I chose the Prusa Core ONE for this experiment. To flip it and not have it sit on the screws, I had to design some new feet. I started by taking measurements with precise tools and designed simple bars that mount through the holes in the top cover. I then chose such a TPU and started printing on my Prusa XL. If you want to print them yourself, you can download them from my printables profile, link in the video description. I installed them with my Fanttik E1 Max screwdriver, which brings us to a quick sponsor segment before we dive into in-depth testing. This part of the video is sponsored by Fanttik with their E1 Max Precision Screwdriver. The E1 Max comes in a compact metal case that holds the driver, 50 S2 metal precision bits, and a few extra tools. With a push, the screwdriver pops out, which is super satisfying. The bits hold magnetically in a tray so that swapping sizes mid-build is quick and everything stays organized while you work. The driver has built-in LED lighting at the tip, 2 torque settings as well as a manual mode, and spins up to 200 RPM. It charges via USB-C, and the 350 mAh battery is rated for over 2 hours of continuous work, making it ideal for drones, computers, phones, watches, and of course 3D printers. Best part, it's affordable, available on Amazon, and with my code you get an extra discount. Check the first links in the video description, select the Amazon coupon, and use my code for a big discount on the Fanttik E1 Max. Thanks to Fanttik for supporting the channel. With the new feed installed, I was able to flip the Core ONE. So let's dive into the testing. Reading through comments under the videos of some other creators, I found that there is a lot of interest in these tests. Stringing, angled prints, overhangs, support-free printing, and print-in-place features. So I decided to go with these models for a first test. Stringing test by Falk, overhang test by Tommy3D, bridging test by Fairfy, and the print-in-place tolerance test by Windrose. I sliced them using the sequential printing feature, which makes the printer complete each individual object one after the other to not affect the test results. I then loaded some PLA filament and printed G-code with the Core ONE standing in its intended orientation and then flipped. While printing, I didn't notice any problems and the bed adhesion was good too. So let's get to the results. Let me show you two prints side by side. Which one is printed upside down? As there are basically no differences, I don't think it's necessary to redo these tests with PETG. Especially for the overhangs, I really would have hoped for some improvements. In my recent design video, I shared a neat trick to avoid the need for supports using a bridging technique. This would have been a great application for upside down printing. But I think that's not quite it. As we all know, hot air rises up. On our regular 3D printer, the heat from the bed rises to the top away from the 3D print. An enclosure usually helps to keep that warm air around the print. With upside down printing, the situation flips, literally. The heated bed sits above the part and the warm air should stay right there where the print needs it. In theory, that could reduce the temperature gradients that cause corners to warp. I thought maybe we can lower the bed temp to save energy and make printing with materials like ABS or ASA easier. To test this, I loaded ASA in the Core ONE and used Extrutim's warping test that I've used in my previous videos. In Prusa Slicer, I enabled the option Draft Shield, which creates a skirt as tall as the tallest object. The idea was to trap the hot air in a pocket around the print. For the first test, I dropped the bed to 70 instead of 110 degrees C, and after a short time, the draft shield fell off. Okay, maybe that was a bit ambitious for the first test. For my second test, I kept the bed properly heated at 100 degrees. The draft shield failed again, but since the actual test piece still stuck to the bed, I disabled the raft feature. After a bit more testing, I got a nearly perfect ABS result with regular temperature settings, door still open. Keep in mind, this test is designed to fail, so that result is pretty good. There might be a slight benefit to printing upside down for warping, but I don't think it's significant. And I still wouldn't print ABS on the Positron's 80-degree glass bed. So, kind of disappointing results. I'm still happy to finally know the answer instead of just guessing it. And watching the flip printer was honestly super fun. You might still want to try it just for the vibes. But from a technical standpoint, right now, I can't recommend flipping your 3D printer upside down. I still have a few ideas worth mentioning. Printer automation could be made easier. If the nozzle and gantry are above the part at the end, the printer could knock the print off the bed into a bin, start the next job, and repeat. And what if we don't stop at upside down? We could flip in all directions, left, right, back, even angled, and see if certain geometries benefit from a specific orientation mid-print. Thinking this further, a gyro or robot arm could slowly rotate the printer while printing, always keeping the perfect orientation. Okay, I think that's going too far. Anyway, I'd love to hear about your ideas, drop them in the comments. Huge thanks to Prusa Research for supporting my new studio. The renovation is still in progress, but it's coming together nicely. Also, thanks to my channel members for the support. Don't forget to like, share, and subscribe, and see you in the next one.